T2 is 320. Cross multiply. When we cross multiply, we have 300 times P2, 22.5 times 320. Okay? So that P2 will be equal to 22.5 times 320 divided by 300. Okay? So let's quickly see what will be the value of this. 320 multiplied by 22.5, and that will give us 7,200 divided by 300. And let's see what will be the value of that. That's everything together divided by 300. And we are going to have 24. And what are we looking for? Pressure. And that pressure is given in Newton per meter squared. Put it there. 24 Newton per meter squared. And that will be the value of P2. We shall consider another question. A given mass of an ideal gas occupies a volume V at a temperature T and under a pressure P. If the pressure is increased to 2P and the temperature reduced to half of T, then the percentage change in the volume of the gas is. From here we are going to have this question is a general gas law, whereby we have PV over T, okay, and that is a constant. But if you are to follow the trend of this question, you are going to have PV over T, P1, V1, T1. And if you look at that question, the question says, if the pressure is increased by 2P, that is our P1 is equal to 2P, you can see that, and the temperature reduced by half, that is our T1 is equal to half of T. Okay? That's what we are having. Then we are told that the volume, if the pressure is increased by 2P and the temperature reduced by half, then what will be the percentage? Then the volume still remain the same, V1. Okay? Let's now see a normal approach to this question. PV over T will be equal to, for P1 is 2P, then for V is still your normal V, then for T is T over 2. Let's say PV over T will be equal to the whole of this. If you try to analyze this, 2P times V divided by T over 2. Okay? And this will give us 2P times V times 2 over T, which is equal to 2 times 2 will give us 4P times V, all divided by T. We are still having PV over T. Then from there, let's multiply PV times T, everything divided by T. What I'm going to have here is 4P times V. T cancel T, PV is equal to 4P times V. So from here now, we can take the whole of this. If you're having PV here, this has cancelled this. We have 4P times V here. Okay? So we are going to get it in terms of volume. And in terms of volume, what are we going to do? This can be as simple as this. we are going to have 4v times p. Is either you have, if you say 4v times p or 4p times p, it's still because they are all connected together with multiplication sign. So from there we can say pv divided by p divided by p. This p will be equal to 4v. So that p cancel p. What we are having is v is equal to 4v. But you remember that this one is v1, where we are coming from. This is v1. Let's make v1 the subject of the formula. 4v1 is equal to v. The whole of this, I put it here, put it there. So that v1 will be equal to 1 over 4v. Yes. But if you look at the question says we should calculate the percentage change in the volume of the gas. Percentage change in the volume. That means the change in volume will be equal to V minus V1. V minus your V is the final volume, initial volume. Final volume will still remain the same V. Initial volume is the one that gives us this value. So we are going to write the value of V1, which is this, for this. 1 over 4 V. This is V minus V over 4 over 1. So let's try to multiply it also. We are going to have, this will give us 4 times V. 4V minus V, everything over 4. 4 times V is 4V minus V over 4. And this will now give us 4V minus V is 3V over 4. Multiply all by 100. Because we have to calculate the percentage change. By 100, we are going to have, so let's try and calculate 3 times 100 will give us 300. That is 300 divided by 4. We are going to have 75%. That is 75%. 75%. And that's the percentage change in that value. You can have fee 75%. We shall consider this question. The pressure, volume, and temperature of an ideal gas are given respectively as P1, V1, and T1. What is the volume V2 of the gas if its pressure is half and the temperature tripled? We are going to come from general gas equation, which is PV over T. We are told that what is the volume of V2 of the gas if its pressure is half. That is, this is for the other side, this is half. For the volume, that's what we are looking for, and the temperature is tripled, which is equal to, let's try and resolve this side. This one is as simple as P over 2 times V2 divided by 3T over 1. Okay? Which is equal to, we can take this one as P over 2, V2, multiply, this one will go up, this one will come down. Which is equal to P times V2, then we are going to have 3 times 2, 60. Everything will still be equal to PV over T. We are looking for V2. Let's cross multiply. PV times 60 will be equal to P times V2 times T. Let's make V2 the subject of the formula. P V times 60. When we have removed this one, we have P T. P cancel P, T cancel T. What we are having left, V and 6, 6V. And that will be the value of V2. We are going to consider a new topic, and that is vapor. Vapor. Under this topic, the candidate should be able to distinguish between saturated and unsaturated vapor. They should be able to relate saturated vapor pressure to boiling point. The